We are going to be talking about conditional probability. I want to remind you that in 3.1, we learned about the probability of some event. P stands for probability. This is some event. We learned, this is review, by the way. You should have this in your 3.1 notes. So, this right here, we said to find the probability that an event occurs, you put the number of outcomes for that event and this time we're calling it event E. That number goes on top, and then the number of outcomes in your sample space goes on bottom. Okay, so a conditional probability is going to be a little bit of an alteration on this right here. This is what it's going to look like. The probability, this reads right here, just like it says right here, the probability of B happening given this straight bar right there is the word, stands for the word given that event A has already happened. Okay, so that's what we call a conditional probability. So this given is and given this A right here, A is the condition. That's why it's called conditional probability. So here's an example. Two cards are selected in a sequence. Notice it said two cards are selected, and they're going to be asking us about the second card. So the event, in this case, this would be like the event B would be the probability, find the probability that you get a queen. Well, it's just not that simple because they're also going to look at that first card that was drawn and they're going to say given that the first card is a king. So given that the first card is a king. So find the probability that the second card was a queen, and we already understand that we saw the first card and we know that it was a king. Well, what does that first card being drawn do to our sample space? Well, if two cards are drawn, remember we have 52 cards in a deck. Okay, so we've got 52 cards. So my sample space originally is 52 cards. Got the word cards. So there's 52 cards in the deck. So my sample space originally was 52. But then I draw that first card out. I'm going to remove that first card. I'm not interested in the probability of what happens with that first card, but I've removed it. And notice right here they said that the king is not replaced. So I took the card out of the deck and I did not put it back. And then I drew my second card. So I no longer had 52 cards in the deck when I was looking for the probability of drawing a queen, given that the first one was a king. Now, the reason that knowing that the first one was a king, it did two things. It changed my sample space. I only had 51 cards left in my deck. And I know that because the first one was a king, I know that I still have 4 queens. So the probability of drawing a queen, we know that there's 4 queens. We've got the queen of hearts. We've got the queen of clubs. And we've got the queen of diamonds. And we've got the queen of spades. Okay, so there's 4 queens, and we know that we have all 4 of them because the first card was a queen, but we only had 51 cards. So that's not the same thing as just finding the probability of drawing a queen. Because probability of drawing a queen is 4 out of 52. But because that first card was drawn, it changed my sample space. So conditional probabilities. are always changing your sample space. Now, this is a little bit different situation. It's still going to be a conditional probability, but it's going to change it's going to change my sample space again, but it's going to change my sample space in a bigger way than just taking out that king did. So on these, what you're going to want to do is be able to, first of all, read what they're telling us right here, and we're going to want to be able to write it down using our probability notation, because that's going to make it easier for us to follow the rules, because you're going to get a formula card, a formula sheet on this test just like you did on the last one, and it's going to have all these rules written down. Well, if you can't read the problem and write down your problem, you're going to have a hard time knowing which rule to apply. So what are we looking for? Find the probability that a user is male. Find the probability that a user is male, given that the user was offended by something on social media. So we're going to put yes, he was offended. And the reason that I know I'm going to put yes, here was the question, have you ever been offended by something in social media? The answers were yes, no. So they're taking not all the surveys, not the 2,276. This is the original sample space, 2,276. This one right here is all we're going to do is use the sample space of just the ones that answered yes. Why? Because that's what it says. Given that the user was offended, given that the user answered yes. So the only group that we are interested in is the group that entered yes. So we entered yes. That's a total of 1,151 people answered yes. And of those that are male is 532. So you would reduce that down if you can, or change it to a decimal. I think it changes to 0.62, which is about 46.2%. But the thing I want you to understand here is that this is the probability that we picked a male, given the probability that they answered yes. So when we have this table situation, the given part changes my sample space in a much bigger way than it did the other one. And the probability that we're drawing male comes out here. And again, how do we know this is that kind? Based on the wording. So we're going to come down here and let's see, refer to the survey in the second part of example 1. Find the probability that the user is female, given that the user was not offended. So was not offended. That means they answered no. Okay, so what are we looking for? The probability that the user is female, given that they answered no for not offended. All right, so with this one, we're only considering females that answered no. So my sample space is the total number of people that answered no. 1125. This is the probability of the no's down here. And then the probability that they are female is what goes on top. And of the no's, the females were 549. Use your calculators to change that to a decimal. Oh, wait, I think I did that wrong. No, I didn't. I was looking at another example that I did on another piece of paper somewhere. But no, that's given that the user was not offended. So this number would reduce to 0.488, and the answer would be 48.8%. Again, either one of these would be fine. And if this reduces down to a nice number, you could leave it in the form of a fraction. But generally, when the fractions are numbers this big, we don't use the fractions. We like fractions to be single digits like 1/2 or 1/3 or something like 4/5. If they're double digit, triple digit numbers, those are not as meaningful and telling as a number that can be changed into a decimal or a fraction, or a percentage. So one more that's not on here. And just because I want to show you that I think on your homework you have to reverse it. What if this one is answering this question down here? So I'm going to do another one. I don't know how to change colors without it being too hard. But anyway, so let's say that I wanted to find the probability that we were interested in the people that answered no, given that they were male. Okay, so I kind of switched things up right here. I want to find the probability that somebody answered no, not out of the total number, but just out of the males. So I would go to, given the male population would go on bottom, the total number of males would go on bottom. And then the total number of people that said no from the male population. These are the males right here. These two combine together to give you that. So these are the no's of just the males. And I don't have my calculator out, but yeah, get your calculator out and change that to a decimal. And that's how you would work that problem. I'm going to stop this video because I think it's right at 10 minutes, and those are longer than 10 minutes are too hard to upload.